Hello everyone, welcome to our this video where we'll be covering two important data structure as per your CBSE computer science syllabus, that is stack and queue. Earlier we talked about built-in data structure in Python. So those were list, tuples, dictionaries, set, strings, and they are uh, designed for certain kind of operations or certain kind of use cases to be supported efficiently. But there are variety of use cases or scenarios where those data structure are not efficient on their own, and out of other data structures outside the purview of built-in one, a stack and queue are two most important data structures uh, that we see. So what we'll do is, in this video we will deep dive uh, and introduce a stack and some of its use cases. We have also read it couple of simulation where you can see that how individual stack operations helps you perform certain kind of uh, algorithmic steps efficiently, and then we'll actually close on this introduction of data structure by a quick intro on Q. Before we move on, from your exam perspective, a stack is very important. Several questions that are tested are around implementation variant of a stack, and we will see at least one example of it. And in our follow-up previous year question paper, we will look at several variation of that uh, implementation tweak that has been that is being tested regularly. So let's move on and talk about the stack in depth. So the stack uh, in your many in your daily use case, right? You might have seen, uh, say when you actually stack book one by one on the shelf or on the table, and just for a moment assume that you can't uh, pick the book from anywhere other than the top of it, right? So with that restriction, if you see, when you are actually going to put, say, series of books or notebook on the table, the one that you are going to take from top will be the last that was put out there, right? So there are certain kind of operations where last in, first out is something that has entered, that was just the last entry, right? They will be processed first, right? And there are a variety of algorithmic use cases where a stack is a very important data structure to implement a variety of intermediate processes and steps. Another example from your real life with your utensils, right? So assuming that vertically uh, you are putting cleaned utensils on top of each other, the one that you are going to pick first will be the one that has been put last, right? So this is a variation that we call last in, first out, right? What is that called? Last in, first out. And with that, let us formally introduce a stack. So a stack is a linear data structure that follows LIFO principle. What is LIFO? Last in, first out. Basically, it is a collection of elements where elements are added and removed only from the top. So you might have seen your list inbuilt data structure, right? You can insert almost anywhere that you want, and that's what a stack does. It doesn't allow you to insert element anywhere. It only allow you to append in a list, right? In a similar way, elements are also removed and processed from the top itself, right? So around these two, addition and removal, there are corresponding operators that are known with name push and pop. So push is the operation where you add an element to the top. Pop, is about removing that element from the top. And there are two utility, routine. Pick, right? Pick is more like you can look at what was the last, what is the element at the top. So more like which book is at the top, right? And based on the length of how many elements are there, we have an utility that will give you whether this stack is empty or not, right? So with that in mind, when we have introduced two new operation, push and pop, and two utilities, that is pick and is empty, let us deep dive on what is this. Sorry, there is some issue with my laptop. Yeah, hopefully we are back. Let us look at an implementation of a stack in Python, which is done around, uh, your built-in list data structure, right? So if you see at the top, we have initialized an empty stack, which is nothing but an linked list. How we have assigned it? We have given a variable name stack and assigned it to an empty square bracket. Then let us introduce our first function, that is push. And what it is going to do, very simple. If you have an element, that element can simply be appended, right? So, and when we are going to append, name of our list here is stack, right? So stack dot append element. When you are going to pop, before pop, applying the pop operation, you better check that whether the stack is empty or not, right? Because many a time it might be that you are attempting pop even without adding an element, or you have done enough pop and then still you want to do more pop. So you are simply checking that this is not empty. It is just about checking the length is greater than 0, and if it is empty, then you simply return none. Otherwise, you are from the underlying list element, you are actually calling its pop and returning the element that is there, which is from the top. So what this pop does here, it will actually remove that element and return it. Then each is empty. It is just simply checking whether the length is equal to 0 or not, and your top element, right? If your stack is not empty, you are just returning the last element by notation -1, and display is kind of iterating through the stack, and until it will empty, we are actually printing element one by one, right? So with that in mind, let us say that we have you are pushing 10, 20, 30, right? What will happen when you push 10? There will be one element at the stack, that will be 10. If you push 20, now 20 will be at the top and 10 will be below. Now when you push 30, 30 will be at the top, and then 20 and 10, right? So with 10, 20, 30, what will happen? Your display will be 10, 20, 30 in that order. where top is at 30, popped element. Now if you pop, what will get? 30. Right? Again you can display 10, 20. Now if you pop, you'll get 20. Right? Then again if you do pop, it will get 10, and then it is empty. Right? So only thing that you need to understand, and only difference from list is both your push and pop is happening at one end, which is at the top. Okay, now let us briefly introduce something called arithmetic expressions. Arithmetic expressions are nothing but what we use, in our day-to-day mathematical expression, right? Say 2 plus 3, 3 into 5, or A plus B into C, right? So the one that we regularly use, where operators plus or minus or into is between operands, say 2 and 3, right? So 2 plus 3, 2, 3 are operand, plus is operator, right? So when you are writing 2 plus 3, that is your prefix. That is your infix. When you write plus 2, 3, that is your prefix. When you write 2, 3 plus, that is your postfix. So how this infix, prefix and postfix notation is coming? Where your operator is in relation to your operands. If it is in between, it is infix. If it is coming first, it is prefix. If it is coming after operands, it is postfix. So you might see example about, say A plus B into C, where operands are on both sides and operator is in between. And you see that in case of prefix, your operator first, then your operands, right? And in case of postfix, your operand first and your operators are at the end. Now with this introduction, there are variety of underlying algos, sub implementation, say for your compilers, right, operating system and others, where uh, even actually a very basic example of calculator implementation, right? So all of that is done in postfix notation. The one that we do day in day out is infix, but the way computer does evaluation of this operator is in postfix. And so we have two tasks using a stack. We will look at how we can convert a prefix to postfix first, and then we'll see that how we can evaluate that postfix. Both of these are as part of your course, and both of these are also tested in one or the other way in your exam. So first, let me list this algo for conversion from infix to postfix. It's actually a long one, almost like all across the screen. But let's start from the initialize part, right? So this is the place where we are initializing empty stack for operators, and we are creating an empty output disk for postfix expression, right? Then we'll start processing the infix expression by scanning from left to right. How we are handling operands? If the scanned character is an operand, that is A, B, 1, etc., right? We are going to append it on the output list, right? How we are going to handling operator? If the scanned character is an operator, that is plus, minus, into, divider, right? While the stack is not empty, at the top of the stack has an operator of greater or equal precedence, right? Pop it and append it to the output. So you understood what we are doing here? Uh, all the operators that you are having, right? Say plus and minus, into and division. For example, into will be at higher precedence, right? So in that way, whenever you are getting, right, whenever your stack is not empty, and at the top of the stack, if you are having an operator of greater or equal precedence, right? So we are talking in terms of your predmas, right? How you are going to execute operators, right? With what precedence, right? So we are going to pop it and append to the output, and then we push the scanned operator onto the stack, right? We'll soon see an example of it, right? If the scanned character is an opening parenthesis, we'll push it into the stack. That's about handling parenthesis. If the scanned character is a closing parenthesis, we'll pop everything from the stack and append to the output unit, until an opening parenthesis is encountered. And from there on, we'll discard the opening parenthesis because that is of no use. So, in case of parenthesis, whenever a left parenthesis comes, we'll push it on the stack. Then operators operands, right, we are going to put them on the stack, and whenever we see and closing parenthesis, everything from current closing parenthesis till last last post opening parenthesis, right, everything will be popped and put on the output list, right. You might have noted, right, on our stack our operands are not pushed, right. It's just like we are using a stack for operators to get them in order, right. So whenever you are going to pop, what you are going to do, you are going to pop items uh, you know as per only these two criteria, right. So whenever there are operands coming, say 3 plus 4, right, what we are going to do, 3 and 4, that will be output as it is from left to right. But when plus will come, it will be pushed to a stack, right. Say then there is into 5, right. So 3 4 5, and after plus into, right. Say that you had started 3 with an opening bracket, right, and then post 5 if there was actually an closing bracket. So 3 4 5 already there, and plus and into, everything would have come. Now this is very important if you look at on handling operators, that whenever you are going to get any operators, right, as long as your stack is not empty and top of the stack has an operator of greater or equal precedence, right, we will pop it and append it to the output, and then we are going to push the scan operator onto the stack, right. So because see what is going to happen, the operators with higher precedence will be executed first, right. So whenever we are getting a new operator, for example, if you are getting plus, right, while on the stack you are already having an into, right, so that into has to come first and your plus can wait. You're getting my point? Because that's the only difference, right. This is the only 2 points that you have to understand, right, about handling operators. As and when you are getting operands that you are going to get pushed into a say output list from same left to right, right, and whenever you are getting operators will be pushed on the stack, right, and let us say first operator came, right, that was plus, you push it. Another operator came, that was minus, you push it, right. Now another operator come, which is uh, you know uh, say into, right, or let's reverse it. Let's say there is an into, right, so into is actually pushed on the stack, and then you get a plus. And you know what is going to happen, since you have got into, everything that was on the stack will be popped, right, and plus will be pushed on the operator. And for parenthesis, your closing parenthesis will be pushed, and then every operator that is coming, it will be pushed as it is. The moment you get a closing parenthesis, all the operators in between will be popped and kind of appended to the output list. So these are the only two things now that you have to understand. Let's take this example: A plus B, right? Parenthesis close, into C minus D, right? And we are looking at postfix expression for it, right? So what should happen? A plus B, right? What will happen? You will start with opening parenthesis, right? That is your initial state. Opening parenthesis. Look at the stack, right, and look at the output part of the postfix. So you're opening, then you are getting A, right? So A will go to your output one, and your stack will have opening parenthesis. Then you are getting plus. So plus will go to the stack, your output will be same. Then you are getting B, right? B will directly go to the output. Then you are getting a closing parenthesis. Now what all is there on your stack? At this point in time, if you see on this part of it, right? So you are actually having only a plus. So your output is AB, and then plus will be pushed out there, right? So then an into will be actually on a stack. Then you are getting C. So C will be outputs AB plus C. Then you are getting minus, right? And when you are getting minus, right, at this point in time, all the operators, right, of higher, greater, or equal precedence will be popped. And since into is having higher precedence, that will be taken. So you are getting A, B plus C into, right, and then you are getting D, right, as it is. and now at top of the stack that is minus, right? So as long as you just understand this into and minus part on the stack or operator, right? Just to summarize, we are actually starting with two stacks. One is for output, postfix as it is. Then one is for our operators, right? Then what we are doing in our operators, whenever a new operator will come, it will be pushed, right? Now there are two scenarios. When a new operator comes, right, and the new operator is of lower precedence than the one that is already in a stack, right? Everything, including all the operators equal to the precedence level of current operator, will be pushed and outputted as it is, right? And as and when you get operand in that order, that will already be kind of put to your postfix postfix stack, right? And then the only difference is whenever there are matching and matching parentheses, right? All the operators in between will be taken in the same order. Hopefully this is clear now. Now evaluation of postfix expression, right? So here we just use a stack to store operands. We stack the postfix expression from left to right. When an operand is in encounter, we push it into the stack. When an operator is in encounter, we will put two operands from the stack and then apply the operation and push the result onto the stack, right? So here what is happening? You are getting operands, you keep pushing them. The moment you get an operator, you push two previous operands. You apply the operation and then push the result on the stack, right? So you can see it. So here the example says 782 into 4 and divided by plus. That's your postfix operator, right? So 782 that will be pushed. You can see the stack situation there. Then you are getting into. The moment you get into the top two operator, 2 and 8 will be taken and multiplied. So that is 16, right? Then 4 is there. So 16, 4. And then you are getting divisor. Now if you are getting divisor, 16 by 4, right? You got 4. And then you are getting plus, right? So 4 plus 7, right? Your output is 11. So this should be easy. Again, take a moment, right? You can actually watch this video again and follow these steps, right? So with this, we have come to end of introduction for a stack. Just as a recap, what we talked about is we introduce what a stack is as an LIFO structure. Then we introduced two special operations, push and pop. Then we actually looked at its implementation, where push is very simple. It's a simple append operation on the underlying list data structure. And when we are doing pop, it is pop again, right? That is supported by the list. And then we are actually carrying is empty and a peep kind of operators for looking at what is inclusion or stack. And we look through example 10, 20, 30 by pushing it and saw the examples. Then we introduced arithmetic operations and then talked about infix to postfix, where we talked about two stacks, one for holding our postfix operators and a postfix operand, another for holding operator, and then we talked about two conditions. The only thing is whenever you get whenever on a stack, when you are getting a new operator, and if on your stack there is an operator with higher precedence, everything starting that higher precedence operator and everything that is equal to the precedence of current operator will be popped out, and if there is a matching parenthesis, all the operators in between, otherwise operands will be outputted as such. We look through this example, then we introduce postfix, when we keep pushing our operands, and when we get an operator, we pop next two operands and take the output. Let's look at a quick quiz. A stack is a linear data structure, yes. A stack doesn't follow LIFO, false. Can a push operation result in underflow condition? Push is going to add elements, so there is no underflow, right? Postfix notation. Operators placed after operands. In postfix, what happens? Your operators are after the operands, right? Okay. So with this, we have come to the end of our stack introduction, right? Now I have actually three important things where I want to show you simulation for a simple stack, and then also a code where we can walk you through with our infix to postfix conversion as well as postfix evaluation. So we'll stop this video here, and when we start, we'll start with our simulation first, and then we'll quickly talk about Q and look at uh, some representative questions that you can expect in your exam. Thank you guys. Thanks for watching this till end. Um, so if you are seeing this content helping you in some way, do like and subscribe, and see you in next video.